Guys, today we're going to start a new unit that is kind of a step away from what we've been doing. It's called correlation versus causation. So some of the stuff we're going to talk about today, it's not going to seem very math related. It's going to feel more logic related. There's some areas that we might even disagree on, and that's okay. But this is leading up to something that we'll be doing tomorrow that involves actually using our calculator, our graphing calculator, which we haven't done a whole lot with yet this year. So again, the lesson right here is called correlation versus causation. A correlation, which can also be called an association. So the two words are interchangeable. So let me just give you an example of something that you can relate to. Sometimes you might have heard someone say, if you would just study more, you'd make an A in that class. Or if you just practice your sport, whether it be football or volleyball or basketball, if you just practice that more, you could be on the A team. And though there's truth to that, though there is a correlation, there is an association between studying and getting better grades, or practicing and being on an A team as opposed to B or C or no team at all. It's not a 100% go all. There are some people that study all the time and they barely pass. And I have other students who don't ever study and they have an A in my class. Same with sports. There's naturally gifted people. They don't have to practice that much and they can still be on an A team, where there's other people working really, really, really hard, and they're lucky if they make it on a B or a C team, if a team at all. So that's what we call like a correlation or association. Yeah, there is a tie-in, but we can't say that the one causes the other. So a correlation or association occurs when a relationship is found between two or more variables. The two words are basically interchangeable. A correlation can be positive, meaning one variable increases and so does the other. Now let's understand that just because there's a positive correlation doesn't mean it's a positive thing. And that's kind of a hard thing to get through our brain. Let me give you an example. As the more I smoke, the more likely my chances of getting cancer. So the smoking is going up, the chances of cancer are going up. It creates a positive trend on if I was graphing the correlation, but it's not a positive thing. A negative, meaning one variable increases and the other variable decreases, would be, let me give you an example of something that you would think of it as I don't want you to think of it as a negative thing. It's just a negative relationship that would create a downward trend on a graph. Example, the more I exercise, the more weight I lose. So that's a good thing. It's a good thing that I'm exercising and losing weight. One is going up, the other is going down. It's going to create a negative slope on a line. Example one, let's look at some examples here. Researchers have found a correlation between teenage drug use and dropout rates at high school. But you know what? There's a correlation. We could line up all the people that have dropped out of high school, and we could say, hey, you know what? A lot of those people use pot or whatever kind of drugs. It doesn't mean that smoking pot makes them drop out. There's plenty of people that smoke pot and they don't drop out, and there's plenty of people who drop out and they don't do drugs at all. But there is a correlation, but we can't say that drug use is causing people to drop out. Example number two, Joe is a manager for a high school football team. He has recorded the points the team has scored every time it rains and recorded it in the chart below. Does there seem to be a relationship? Like, look at these dots. There definitely seems to be a positive trend here. It seems that the more it rains, the more that they score points. So this is called a positive correlation or a positive trend. Is Joe saying that rain causes the team to score more points? No. But there does seem to be does seem to be a correlation. But definitely the rain is not causing them to score more points. Well, I could go into a bunch of different examples, but I'm not going to. Okay, a correlation coefficient is a number, is a number that measures the strength of the relationship between the two variables, of how good the relationship is. In algebra, we call this the R value. This number is created from the line of best fit. The closer the correlation gets to +1, the stronger the positive correlation between the two variables. This means that the scatter plot almost looks like a straight line. And that means I have a bunch of dots, but they're so close together you could almost connect them like a straight line. The closer a correlation coefficient gets to 0, either positive or negative, the weaker the correlation between the two variables. This means the scatter plot almost looks like there's no correlation. Like you might see a bunch of dots and maybe they kind of look like they're going upward, or maybe they look like they're going downward. But the closer it gets to 0, the more they're kind of all over the place. Okay, the closer a correlation coefficient gets to -1, the stronger the negative correlation. Again, and we're going to look at some pictures of this, and that'll make a whole lot more sense. So let's just go ahead and look at these pictures. You can here see when there's an R value of 1, just how much it almost is like a straight line. And when it's closer to 0, they're all over the place. You almost can't even say there's a relationship between the two. You can see a positive trend here. You can see a negative trend here. Okay, a causation. All right, and then this is where you could get into some discussion, is when there is either an obvious or scientific proof that the changes in one variable measured directly cause the changes in other variables. Sometimes the proof is very logical, but most of the time the proof must be measured, kind of like scientifically. For example, throwing your phone off a cliff causes the destruction of your phone. Would this be a correlation or a causal relationship? Now, I didn't say casual, I said a causal relationship. Now, you could say both. I mean, obviously, if I throw my phone off of a cliff and it's broken, I could pretty much say, you know what? It's because I threw my phone off of the cliff. That's what causes it to break. And if we threw a bunch of phones off of a cliff, depending on how big of the cliff, a lot of them would be broken, but not all of them would be broken. So I could break my phone another way. I could break my phone by just having it in my purse and dropping my purse a certain way. So I got a crack in my screen once because my dog bit down on it. So not all broken phones are from dropping them off a cliff, but we can definitely say that dropping a phone off a cliff is probably going to break your phone. All right, let's look at another one. A controlled experiment shows a 0.84 correlation between the number of cigarettes smoked and an increase in lung cancer in trial groups. Is this study saying smoking cigarettes causes lung cancer? You know what? No, it's not saying that, but there's a very, very, very strong correlation. There's other people that get lung cancer for other reasons. And some people who smoke all of the time will not get lung cancer. Is there an association? Yes. Or I should say a correlation or association. Yes, there definitely is. Okay. Last one. A scientific study shows that when you cut the number of calories you intake each day, you lose weight. Does eating less calories cause you to lose weight? Yes. Now, there are some people, myself included, that have a thyroid condition. So that affects calories, how much they affect me. Um, so there is, but there is scientific proof, because calories, the the kind of the idea that the more calories you burn, the less calories you take in, it causes a deficit and you lose weight. So there's a scientific study that. So clue in on that. When you see something that talks about a scientific study that's proving something, almost always you can say that that is causation. So that's just a little hint right there about causation. Some sort of a scientific study that's done that's proving it one way or the other. So, some key points here. A scatter plot could have a correlation of +1 or -1, and there it still could not be causal. It could be really close to it, but it doesn't definitely 100% say it's causing it. But listen carefully. In order for there to be a causal, in order for that to be, there has to be a correlation. So if you have a scatter plot with dots all over the place and there's no real correlation between the two, there's no way you're going to find that there's a causation. Correlation must precede causation. Next point. It is often hard to prove causation, or correlation is typically easy to determine. So I have a cute little video for you to watch. It might help you a little bit more with this idea. Good luck with the assignment, and I'll see you next time. Bye-bye.